Okay, gang, so today we're taking what we learned yesterday about solving equations with variables on both sides and turning them into word problems that have to be solved with variables on both sides. Let's take a look at the procedure. First, you're going to read the problem. Obviously, you need to read the problem and make sure you understand what it's being asked. Do not start writing the equation right away. Read it thoroughly first. Second, determine where to put the equal sign. Wherever the word is usually where you put the equal sign. As soon as you see the word is, that's where you need to place your equal sign. Third, write an equation that models the problem. Fourth, solve for the variable. Seems pretty simple. It does get very challenging, so stay with me through the examples. Number 1, 3 times a number is equal to 36 less than 5 times the same number. I've read it once. I saw the word is. Where the is where I need to put my equal sign. So 3 times a number. That's 3x is equals to 36 less than 5 times the same number. Remember that less than, we've seen that a couple times already, or more than. You want to turn that problem around. 36 less than 5 times the same number is not 36 minus 5x. It's 5x minus 36. You're taking 36 away from the 5x. So now we have a simple problem, very similar to what we saw yesterday in class. So now we want to balance the equation. I've got one term on the left, two terms on the right. So I want to take one of the terms from the right and move it over to the left. Since the left has an x already, I need to move the x term from the right over to it. The 5x is positive, not negative. That negative refers only to the 36. So I'm going to subtract 5x from both sides. Gives me negative 2x equals negative 36. Divide by negative 2, divide by negative 2, and x equals 18. Final answer, 18 is the solution. All right, let's take a look at the next one. Jumping to number 2. 15 more than 1/3 of a number is equal to 12 less than 4/3 of the same number. Similar problem, we've got some fractions. I've read it once, I'm thinking about it. Now I'm going to read it again. 15 more than 1/3 of a number. So 15 more than 1/3 of a number is 1/3 x plus 15. Adding the 15 to the 1/3 because it's more than it. Is equal gives me the equal sign to 12 less than 4/3 of the same number. 12 less than 4/3 of the same number is taking 12 away from 4/3 of that same number. So 4/3 x minus 12. There's our equation. So now, since we have x's on both sides and constants on both sides, I'm going to start by moving the smaller coefficient of x over to the opposite side of the equation. 1/3 is smaller than 4/3, so we'll subtract that from both sides. So 15 equals 4 minus 1/3, or 4/3 minus 1/3 is 3/3, which is just 1. So x minus 12. Add 12 to both sides, and x equals 27. Done. Final answer, solution is 27. All right, let's see what we have next. Number 5, jumped up. So now we've got a more challenging word problem that we might have to set up a lot before we dive right into writing it. So Emily's great Aunt Grace is 6 times her age. If you subtract 28 from Aunt Grace's age and add 11 to 3 times Emily's age, their ages are the same. Find their ages. So we have Emily and great Aunt Grace. I'm going to call her Gag for now, just to simplify that. I don't want to write it all over again. All right, so Emily's great Aunt Grace is 6 times her age. Aunt Grace is being compared to Emily, therefore Emily is X, and Aunt Grace is 6 times X, 6 times Emily's age. Now we can start setting it up. If you subtract 28 from Aunt Grace's age, so 6x minus 28, and add 11 to 3 times Emily's age, their ages are the same. Add 11 to 3 times Emily's age, so 3x plus 11. And then their ages are the same. That's why I put the equal sign there. All right, so again, I have coefficients of x on both sides. I have constants on both sides. Let's start by moving the smaller of the x over to the opposite side. So we have 6x and 3x. 3x is smaller. I'm going to subtract it from both sides. Therefore, 3x minus 28 equals 11. Add 28 to both sides. 3x equals 39. Divide by 3. And x equals 3 goes into 3 once, 3 goes into 9 3 times, 13. So Emily is 13, and her great aunt is 13 times 6. 6 times 3 is 18, carry the 1, 78 years old. Please ignore the phone for 1 second. Oh, they hung up. I'll cut that out later. All right, next problem. Jumping to number 7. Find two consecutive integers such that the larger is 9 more than twice the smaller. All right, so we go back to the idea of consecutive integers. So first we have to set it up. Find two consecutive integers. Remember, the first is always x. And this is just consecutive, not consecutive even or odd. So the next would be x plus 1. Such that the larger is 9 more than twice the smaller. Well, the larger would be the second number here. So this is going to be small. This is going to be larger. So now I want to think about this some more. Find two consecutive integers such that the larger, so the larger is x plus 1, is, that's where my equal sign is, 9 more than twice the smaller. 9 more than twice x would be 2x plus 9. That gets a lot more challenging. Now I have what looks like a simple equation. We use the same procedure that we've been doing. I have 2x and x. I want to subtract x from both sides. So 1 equals x plus 9. Now I want to get rid of that positive 9, so I'm going to subtract 9 from both sides. So x equals negative 8, which is an integer. It's a negative number. We can have negative numbers as an answer when we're talking about consecutive integers. So our first integer is negative 8, and our second wouldn't be negative 9 because that would not be larger. That would be smaller. It would be negative 7. So our integers are negative 8 and negative 7. All right, let's see what we got next. Number 9. Find three consecutive odd integers such that 8 more than the sum of the first two is equal to 11 less than 3 times the third. All right, so we've got three consecutive odd. Remember, first one's always x. We're talking odd numbers. They're 2 apart, so x plus 2, then x plus 4. Now we can build the word problem. Find three consecutive odd integers such that 8 more than the sum of the first two. Here's the first two. Their sum is 2x plus 2. 8 more than that. So 2x plus 2 plus 8 is equal to 11 less than 3 times the third. Oh, that's tricky. So here's the third. We want 3 times of that whole thing. So 3 times x plus 4, and it's 11 less than that, minus 11. Whew, hopefully you followed how I set that whole thing up because you will see ones just like that, if not more challenging. So now we need to go through and solve by combining like terms on opposite sides, getting rid of the parentheses, and then simplifying. So over here, we've got this 2x plus 2 plus 8, so we can change that to 2x plus 10. Over here, we've got the parentheses we need to get rid of, so we've got 3x plus 12 minus 11. Simplify that one further step. 2x plus 10 equals 3x plus 1 because of 12 minus 11. Now I've got x's on both sides. I'm going to subtract the smaller, minus 2x. So 10 equals x plus 1. Subtract 1, and x equals 9. So now my three odd integers are 9, 11, and 13. Done. All right, so hopefully you're following along and understanding how I'm getting these equations. I have no more for you, so you're going to go back and do the ones I didn't do with you. Check in with your partner, raise your hand when you've got them done so I can check to make sure that it's correct